Hello and welcome. In this video, let's have a look at measuring with 2D metrology. With this approach, you can very precisely measure objects that can be represented by specific geometric primitives. For example, here, we want to measure the radius of these washers. Using the camera parameters and the pose, we want to perform the measurement in millimeters instead of pixels. The pose defines the measuring plane in the world coordinate system. First, we create the metrology model, which is stored in a handle. After that, we use Set Metrology Model Image Size for an efficient measurement. Then, we can add various metrology objects to this handle. In this case, we want to measure a circle. Here, we need to specify rough values for the center point and radius of the circle. For now, we leave row and column at 0. In the graphics window, we determine that the radius is approximately 260 pixels. Additionally, we could adapt measure length 1 and measure length 2, which influence the measure tolerance. More on these parameters later. Next, we step into the loop that loops through all of the images. Here, we need to determine the rough position of the washer. First, we threshold the image. Then we use area center to determine the center coordinates of this region. Lastly, we use Align Metrology Model to align the circle measurement according to these values. Now we can perform the measurement with Apply Metrology Model. To query the results, we use Get Metrology Object Result. Now, parameter contains the measured row and column of the circle center and the radius in pixels. Additionally, with Get Metrology Object Result Contour, we can access the measured circle. Now, as promised earlier, let's have a closer look at the parameters measure length 1 and measure length 2. With Get Metrology Object Measures, we can access the measure rectangles that are used internally by the metrology model. Measure length 1 and measure length 2 specify the height and width of these rectangles. The rough values for the circle specify the center points of the rectangles. With Gen Cross Contour XLD and the output coordinates of Get Metrology Object Measures, we can visualize the edges that were found in every measure rectangle. Internally, these edges are used to fit in a final circle. Lastly, we want to calibrate this measurement setup. Thus, at the beginning of the program, we can use Set Metrology Model Param to set the camera parameters and the pose of the measurement plane. Now the results in parameter are in meters. Let's quickly convert this to millimeters and round it to 3 decimal places using this line of code. The x and y coordinates are relative to the origin that was defined during the calibration by the image of the reference calibration plate. The radius is roughly 12 millimeters. Now, as a last step, we should use Clear Metrology Model at the end to free the memory used by the metrology model. This concludes our video on calibrated measurements. You should now be able to create your own basic measurement applications. For more complex applications, have a look at the solution guide on 2D measuring. Check out our YouTube channel for more tutorials and information about our products. Thank you for watching.